Hi there. This is the solution for cisp310 in fall 2018 semester, and this is for the Monday, Wednesday class for question number 2. All right, so for question number 2, this is the signed right shift exercise or question. It is not recursive. It's really just to test to see whether people understand how to set up a subroutine and the basic stuff about conditional statements. The only thing that is quote unquote tricky is the right shift operation. But we talked about that instruction, and it is certainly a part of the ALU. So it is a part of the material that we are supposed to use supposed to know in this class. All right, so let's go ahead and get started with this one. So the way I'm going to do this is let's do it this way. It's not selecting the tool. That is rather odd. There we go. Okay. All right. So the first thing I'll do is I'm going to define some of the labels, just so that it's easier to refer to the code. So SRSH is the name of the subroutine, and we also know that it has got a local variable m. Okay, so we'll do a decrement d to allocate for the local variable m. And then at this point, I can define symbolic names of the offset to each item on the stack. So we'll start with the one right at where the stack point is pointing to, which is m, the local variable. So we'll say m is defined to be 0. The next one up is the return address. Okay, if you prefer 1, that's fine. You can also say m1 plus, which is 1 plus m. And then the next one up is going to be x, which is going to be return address 1 plus. And then the next one up is going to be y, which is x1 plus. So having these symbolic names kind of help to, so I don't have to think about or worry about, where are my items on the stack later on. And then the code in between is like, okay, so we got some stuff in between, but I'm more concerned about just returning, at the end here. So I'm going to write the return code right away. Okay, so we can have a LDI AX add AD. So A is now the address of parameter X, and then we need a dereference. And that specifies the return value, and then we have the usual return sequence, which in this case we also have to remember to increment, because we have to deallocate the local variable m. So we increment d, and then we have a LDBD to retrieve the return address, increment d again to deallocate the return address, and then a JMPB to get back to the caller. So this is the beginning and the closing of the entire subroutine. So in between here, okay, we can now insert the code for the conditional statement and also for the while loop. Because the conditional statement and the while loop are at the same level, I'm going to do both of them at the same time. So with the conditional statement, we'll do a LDI AX, and then do add AD, and then do LD AA. So now a is parameter x. We want to see if it is less than 0. There's a quick way to do it without actually comparing. We can say and AA, and then the JSI in this case, because the sign bit is all that I need to see whether it is 0 or excuse me, if it's whether it's less than 0 or not. So if it is, then we go to the then label. Otherwise, we jump to the else label. So here's the then label. We'll do something here and then jump to the and if label. And here's the else label. We'll do something here and then we'll get to the end if label here. And at the end if label, which is corresponding to kind of right after line 11 in the C code, now we need to write the loop. So we'll start the loop here. Every loop starts with a while begin or a label to indicate the beginning of the loop. And then the condition to stay in the loop is when y is non-zero. Okay, so we have to get y first. So we do LDI a y, add AD, LDAA, and then we do AND AA. So we are now checking whether this time we want to look at the Z flag. And if the Z flag is set, JZI, we go to while end, because that means we are done with this loop. Otherwise, we proceed with something here. At the very end of the loop, we need a JMPI back to the beginning of the loop, which is marked by while begin. And while end goes here. So this code, this chunk of code here handles the second level in terms of a hierarchy of the code. So now I need to worry about the most embedded level. So line 6 is going here. So on line 6 we have m equals to 128. So there are a few ways to do this. The most obvious way is just to do a LDI AM, add AD. So now we have the address of local variable m, and then we just do a LDI B128, and then we do ST A, because A is the address of M already, so we store B, which is 128 into it. So this chunk of code is the then block of code here, and then the other one is kind of the same, LDI AM, add AD, LDI, B0 this time, and STAB, and this is the else case, so this one goes here. And now we need to look at the body of the loop on lines 14 and 15. So line 14 is a little bit more complex, because it has got the shift operation. It's got the shift operation and the decrement of y. So we'll deal with those one by one. So we'll deal with the right shift operation first. Okay. So we have to do LDI AX, add AD, and then we do LD AA. So now A has the value of X, and we might want to keep that around. Okay, so so we'll try to keep A around a little bit, because never mind, I destroyed that A already. So we'll just assume that we have to recalculate the address of X later on. So now we need to right shift by 1. there's no easy way to right shift by 1, so you got to load B with 1, and then we do a right shift. A specifies the bit pattern to be shifted, and B specifies the number of bits we're going to shift it. So now the result is in A. We have to OR that with M. So we have to do LDI. I cannot use A anymore, but I can certainly use B with M. And then we add BD. And then we do LD BB. So now B is M. And then this one is just an OR. So we are ORing, but we have to store the value of M into, excuse me, so we have to, doesn't really matter which way, because but in this case register A becomes the result of the entire operation, and we have to store that into X. So as I said a little bit earlier, I could have saved myself a little bit of trouble by keeping that around. So we have to load B with X again, add BD, so B is now the address of X, and then a single store instruction to where B points to, which is X, with A, which is the result or the value of the right hand side. We get the job done, and I'm just going to continue here because the only thing left is the decrement of Y. So to do that, we do a LDIAY, add AD, but this time I remember to use a different register, LDBA. So the B is the value of Y, but A is the address of Y. And then we do the decrement of B, and then we store that back right away, and that accomplishes the decrement of Y. So this chunk of code is supposed to go here. Now the question also says you have to use minimal comment to associate code to the line numbers. So I'm just going to say, I can use a different color here, and returning X is done by this here. Oh, I can use some line numbers, so that makes it easier. So the line number is 17 in this case. And then the checking of the condition, this part is basically line 4. The checking of the condition of the while, this is basically line 12. And then the then branch, oops, my hand is touching the other part of the screen that you cannot see. That's the reason why we're seeing all that stuff. Okay, so the then branch is line 6. So this is basically doing what line 6 is supposed to do. This is the else branch, which is on line 10. And then this part here, let's see. So all the way from here down to here is line 14. And the decrement of Y is this part. That corresponds to line 15. The closed curly braces typically, do not need to be numbers. So if you don't tell me where they are, that's okay. You can extend line 17 to cover the entire thing, because the return statement in C does both. It specifies the return value as well as continuing execution in the caller. This part here is not really needed, but if you put it in, certainly not wrong. This is basically line 3. And if you want to label the end of stuff, okay, then we got, this is basically line 7, and then the end if is sort of line 11. I'm not going to put it there. The end of the while loop, which is this part here, is kind of line 16. So once again, those are not really needed. For commenting, let me use another color to indicate what I will be definitely looking for. This I'll be looking for, this I'll be looking for, this I'll be looking for, and then the blocks inside the control structures. Those are all the ones that I'll be looking for. So there you have it. This is how I'm going to grade the exam. Well, this is part of how I'm going to grade the exam. The grading is going to be based on whether I can see that you understand the concepts involved here, passing the parameters. The second parameter has a higher address than the first one, so that's one concept. How to return the value using register A, that's another concept. Local variables live on the stack below the return address, that's another concept. Remembering to deallocate the local variable at the end, that's important. And then the implementation of the statements is also kind of important, the control structures. And then how to access the items on the stack is also going to be important. We have to compute the address first based on the offset from where the stack pointer is pointing to, and then we dereference to get to the values. And then the use of LD to read something on the stack, and the use of ST to store something on the stack. So those are all the concepts that I'll be looking for when I grade this particular question. All right, so when I'm done with this one and start to work on another one, I will inform you again. I think, okay, the recorder just, I think it recorded a different portion of the screen. So I'm not really sure whether it got the right part recorded or not. I have to go back and check. If not, I will post the grading criteria online, and yeah, I'm pretty sure it's not working because I think no, I'll check.